Hello everyone, and welcome back to the Programming and Coding Basics with VBA, Python, and Java with JavaScript, brought to you by QuadRoot R&D, where we will learn to code from scratch in 3 different languages and understand the commonalities between them in just 3 hours. Now, Abraham Lincoln once said, "Give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe." Well, that's exactly the philosophy of this course, and in fact the very same ratio. For the first 2 hours of this 3-hour course, we are going to sharpen the axe by understanding the concepts first, before we get our hands dirty with the coding environment, so we know what we are doing by the time we reach there. Now in part 1, we discussed the overview of programming, the what, the why, and which language. In part 2, which comprises about half the course or around 1.5 hours, we are going to discuss the how, by understanding the main concepts of programming and their applications common across all programming languages, with syntax examples from the 3 that we have chosen. The intent is to be agnostic about programming and not favoring any one code to begin with, to show that no matter what language you choose, the concepts are pretty much the same. Now in this video, we are going to discuss programming at a top level. Remember how we discussed the subtle difference between programming and coding? Well, this video is about the larger process of programming, which is essential to plan your program using the modular approach and the 4-step problem-solving process, which we'll use to strategize and write the algorithm, which is the skeleton of your code. From the next video onwards, we will go into the nitty-gritty of coding to flesh out that algorithm, where we will cover the basic definitions, data types, input and output statements, processing statements like operations, control flow statements like loops and branches, user-defined functions, built-in functions, and end with a code walkthrough of the game Mastermind. By the end of part 2, you'll be able to read most programs and have a good idea of what's going on, provided you understand the logic and it's well commented, and it won't look like Greek to all the non-Greeks out there. In part 3 of this course, which will be about an hour or so, we will finally get our hands dirty with how to get started with coding yourself and putting all the knowledge gained from the first 2 parts into use in a practical pseudo-AI exercise. Now, starting with modular programming. A module is an independent, self-contained section of code that performs a major task. Complex modules can be broken into submodules, and those submodules may be further broken. In top-down design, the main module is the module that controls all other modules, and that control transfers to the called module, which feeds it back to the main module when it's done. And we follow what is known as the hierarchy of inputs, processes, and outputs. The main module calls the input data module, which collects the inputs in the form of user inputs or events like clicks, scrolls, or changes, or text or CSV file reads, or even database reads. Now this data goes back to the main module, which then calls the processing data module. This is where the magic happens, like operations like calculations, data manipulation, repeating operations, or logical checks. And this process data then gets outputted into the output module, which displays or alerts or even reports, or it could be in the form of an event, or it could update a database. Now what this all means is that modular programming approach is like a team leader who breaks down a project to manageable tasks and delegates each task to a team member. And it will be done sequentially in most cases. The input of one module depends on the output of the previous module. For example, the input for the process data depends on the output of the input data module, and it cannot start until this is done. Now we adapt Polya's 4 steps for problem solving to programming in order to achieve the desired outcome. So it's not enough to know a particular programming language. You must be able to problem solve and strategize. It's problem solving that distinguishes a great programmer from a good one. Some argue that it is an innate skill which you cannot teach, but following these 4 steps would give you a methodical approach to arriving at the most efficient solution. Now the first step is understand the problem, or in short, analyze. What is the problem? What is the unknown? What is the condition? What is the data available? and needed. So you identify the inputs, outputs, and the processes needed to produce the outputs from the inputs. For example, if the goal is to calculate the speed of travel using a mobile app, say a speedometer app, what would be the inputs required? Real-time GPS data. But at what frequency? At what accuracy? What processes are required to obtain the speed from the available data? A calculation. You need a formula that equates speed, distance, and time. How will we output the data? At what frequency? The next step is to devise a good plan and efficient strategy to solve, or in short, design. The most important step is the algorithm, where you make a list of finite, unambiguous actions to accomplish the solution. Now, in the code, we implement the algorithm as comments, which are not actually executed, but they're just there to guide the programmer to code. Remember that I mentioned in the previous video that writing a program is like a master chef writing their signature recipe into clear, unambiguous steps that anyone can follow. This is it. It's the algorithm. Now you can visualize the algorithm in the form of a flowchart. And it makes things easy to visualize. It can be skipped for simple programs, but if the program is very complex, involving lots of decisions based on checking of certain conditions that will direct the flow of code one way or the other, then the decision symbol of the flowchart is useful to visualize the flow of the program. If a condition is met, then go to one side of the code. If not, go to the other side of the code. Those are called flow control statements, and we'll be going into them later on. For example, I recently had the need to draw a flowchart while calculating the time duration of a test based on various sources of data, as no single source of data was consistent or reliable enough. So after checking the reliability of the primary source of data, if it didn't seem reliable, then there were two more options that I had. If none were reliable, then I had to guesstimate it from different sets of data based on past data. Also, if you need to document your code, which is always a good idea professionally, then including a flowchart of the algorithm is a must. Now, pseudocode is written as English-like program code without syntax, possibly a future higher-level language before NLP. So you can imagine pseudocode like an old-school science fiction movie where the scientist speaks to the computer in short English commands without any grammar. Computer, print all stars in quadrant 437 alpha. Now, going back to our speedometer example, how would we obtain the inputs? Do I ask the user, or can I get it from elsewhere like a database or live data from a sensor? Obviously, a GPS sensor. Okay, now that you got the data, what's the data format? Do I need to clean it or convert it? It depends on the application of the data. Now, I have two data points between point A and point B in latitude and longitude coordinates. What I need next is the distance. I would need the distance formula to calculate the distance between 2 point coordinates. For example, now if this is x1 and y1 and this is x2 and y2, then the distance between them is calculated as x2 minus x1 the whole square plus y2 minus y1 the whole square root, which is essentially another form of Pythagoras. Now the coordinates would need to be at a sufficient accuracy of about 6 decimal places, at least. Okay, so what's next? You calculate the speed as distance upon time. But wait, what is the time? It's the difference of timestamps between the two measurements at point A and point B. Do we have that readily? So we should do that before calculating the speed. Once we have that, then we can calculate speed equals to distance upon time A minus time B. Great, so we got our result. But now we have to output it. How do we do that? Do we plot it? Do we display it? Displaying is more appropriate. At what accuracy? Maybe we wouldn't require decimal places, so an integer should suffice. Now that we've got the algorithm and flowchart, it's time to implement the plan, that is, code. See how coding is just one part of the overall programming process? So you implement the programming language, checking line by line as you go. The final step is to evaluate the solution or test. So if you did the previous step properly, checking line by line, then you should be free of debugging errors. But once you finish, you can test the code for syntax and logical errors, debugging, and for quality and usability issues. You look for better, easier, more efficient solutions. You check results repeatedly using highly varied and unexpected test cases or data sets. For example, you have to be careful of GIGO errors. Garbage in, garbage out. Expect the unexpected. There are two phases of testing. Alpha testing, which is the internal testing that we've talked about, and there's beta testing, where we go to the customer side and test with live data. So that brings us to the end of the programming process, but I cannot stress enough how important it is. Coding is the easy part, believe me, but it's the algorithm that differentiates between an average programmer from a great one. It's their logical thinking process that sets them apart. This is what I meant when I said programming teaches you how to think. It forces you to think of solutions using the tools of coding. So if you have an idea that you would like to implement, have a think about it from the problem-solving point of view. Try and use these steps to achieve what you want to do. It doesn't have to be super detailed for now. In the next video, we are going to start with coding, where we will discuss the basic definitions, data types, and declarations of variables. Be sure to subscribe to this channel and click the notification bell to receive notifications when the next video is posted. If you've reached this far, then now's the time to like this video and share with a friend. See you in the next video.